Hey guys, so let's take a look at the program to print n terms of the Fibonacci series using recursion. We've already done a program to print n terms of the Fibonacci series using loops, which I have linked in the description box below. So what is the Fibonacci series? The Fibonacci series is a set of numbers following the order 0, 1, 1, 2, 3, 5, 8, 13, 21 and so on. So now we know the first term is 0 and the second term is 1, or let's say the 0th term is 0, the first term is 1. If n is equal to 0, print 0. If n is equal to 1, print 1 and so on. Calculate. Now, while it's very common to form a mistake over here when you write the recursion program, I'll tell you why. So like we have seen a factorial program, let's try to degrade this into smaller values. So let's say n is equal to 5. I want to print the value of Fibonacci 5. So Fibonacci 5 is 0, 1, 2, 3, 4, 5. The value is 5. This value of 5 is generated by adding 3 and 2. What is 3? It is 0, 1, 2, 3, 4, meaning the fourth Fibonacci term plus the third Fibonacci term. Now the fourth Fibonacci term 3 is gotten from adding 2 plus 1, and the third Fibonacci term 2 is gotten by adding 1 plus 1. Now this 2 plus 1 is fib of 3 plus fib of 2 plus, and this 1 plus 1 is derived from fib of 2 plus fib of 1. Got it? Now this fib of 3, again you can get it from, see, the fib of 3 we made it as fib of 2 plus 1. So eventually you will find it as in this format. I will write it in tree format. It will be easier for you to understand. Now fib of 5. Fib of 5 is followed by the addition of Fibonacci of the third term plus Fibonacci of the fourth term. 3 is gotten by Fibonacci of 1 and Fibonacci of 2. Fibonacci of 4 is gotten by Fibonacci of 2 plus Fibonacci of 3. Just take off this. Okay. Now Fibonacci of 1 is 1 by default. Fibonacci of 2 is gotten by Fibonacci of 0 plus Fibonacci of 1. This is 0 and this is 1. Fibonacci of 2 again is gotten by Fibonacci of 0, which is 0, and Fibonacci of 1, which is 1. 3 again you will have to dissect into Fibonacci of 1 and Fibonacci of 2. This Fibonacci of 1 is 1 and Fibonacci of 2 is again Fibonacci of 0 and Fibonacci of 1, and this is 0 and this is 1. So once we've reached numbers, we have done the loop. We have finished. So following the similar method that we did for factorial and for sum, you can easily write that if the function was int fib and n is passed, right? If n is equal to 0, this is n, you will return 0, because if Fibonacci of 0, 0th term is 0. If n is equal to 1, you return 1. You return 1. You can combine these both and you can write it as, if n is equal to 0 or n is equal to 1, you return the respective n values. Okay, if n is equal to 0, return 0. If n is equal to 1, return 1. So this is the respective n values you can return. Else, the Fibonacci of a number is actually returning Fibonacci of n minus 1 plus Fibonacci of n minus 2. Great. So we have done like how we did our sum and how we did our factorial program for for recursion. We have done the Fibonacci. Every Fibonacci is the value of the sum of the previous two numbers. But there is a problem with this. When you calculate all these, you are only still reaching a single term. You are not reaching the series. This will help you to calculate the Fibonacci value of a particular nth term. It will not print the n terms. It will help you in calculating the nth term of the Fibonacci series. Now our program is to print all n terms of your Fibonacci series. For this, what you have to do is, in your void main, once you take the value of n from the user, you can write for I is equal to 0, I less than or equal to n, I plus plus, print the value of that Fibonacci term of I. Do this in the main program, and when I is equal to 0, it calls Fibonacci of 0 and it will print 0. When I gets the value of 1, it will calculate Fibonacci of 1 and print 1. When I is equal to 2, it will calculate Fibonacci of 2 and print it as 1. When I is equal to 3, it will calculate Fibonacci of 3 and print it as 2. So, like your factorial and your sum program, do not make the mistake of ending up writing only what is there inside this box. Because this box is not printing the entire series of your Fibonacci. It is only used for printing the nth term of your Fibonacci series. Now we look at this in the coding part. Okay, coming to the printing of n terms of the Fibonacci series using recursion. So I'll first show you the common mistake that we make is just calling fib of n and expecting the entire series to print. After that, I'll show you how we'll alter it to print the actual Fibonacci series. So let's start with our void main. I'm going to ask the user for the value of n, so I need n. So printf /n, enter n, and scanf %d ampersand n, and we'll print. So I'll be printing printf Fibonacci series, and this will start with %d comma fib of n. Okay, and we'll write int fib with parameter int n, and the condition was the first term is 0 and the second term is 1, or when n is equal to 0, 0th term will be 0 and first term will be 1. So the condition will be if n equals to 0 or n equals to 1. Whichever is these conditions becomes true, it should return the corresponding value of n. So return n. Now moving to else part, we have to return the value of fib of n minus 1 plus fib of n minus 2. So this is the value we're supposed to print. It's a common mistake that when we write this, we expect that all the values of the Fibonacci series will be printed. Let's run it. Enter n. So the fifth term of the Fibonacci series is 5. So when you put 5, it doesn't print 5 terms, it only prints the fifth term. This is the common mistakes that we make. Now instead of that, what I will do is I will keep a loop variable I, and I want it to start from the 0th term, go up till the nth term. I plus plus, and for each value I wanted to print the Fibonacci value of I. If I write like this, for each and every value it's going to print. So I'll remove this and print it separately over here. Print F, Control V. So it should print outside and it should print the value of the Fibonacci series inside the loop. Let's run it and see. So for n is equal to 5, it should print till the Fibonacci series value 5. 0, 1, 1, 2, 3, 5. So let's run it for the value of 10 once again. There it is, printed. Now before you watch this video, if you go on to the Fibonacci series using loops, which is linked in the description box below, it will be easier for you to understand how does the exact calculation of the Fibonacci series value is seen. And using recursion, you can print it using recursion. Thank you.